Hi, this is Dave McComb from Semantic Arts. Today we're going to do a little case study of something we just had to do recently that I thought might be a nice learning opportunity. It's where we had an existing ontology and we decided to convert something that was not temporal to be temporal, and don't worry, I'll explain what all that means. Let's get into it. So here's what happened. We've actually been running we have a consulting business. We've been running it for several years on semantic technology in a triple store. And for most of that time, all of our consultants had a standard billing rate, and that was good enough for what we were doing. But recently we decided we were going to have incentive pay for consultants. That pay was going to be based on their contribution, and it was going to be based on their contribution over time, which led to a need to track billing rates over time if they did change. So that's the basic situation. So we've already got a database. It's got 5 or 6 years worth of time and charges and projects and clients and all that kind of stuff in it that we're going to try and update in place. But before we do that, a quick word about what temporality means in semantics and why people get interested in it. It just means considering things over time. That obviously everything changes over time, and how is your ontology going to deal with that? As near as I can tell, there's pretty much 3 camps on this. There's one camp that says everything's temporal. Everything can change. Everything therefore should be flagged with effectivity dates. And there are some cases for this, especially the so-called immortal databases where you want to write once and never update in place, never delete. But they are a bit more complex. Takes a lot more to do. You really should be building that into the architecture. The second camp is model everything quote correctly the first time through. Most of the folks who believe in that there's a major difference between continuance and occurrence, or endurance and pedurance, and you can go look those things up if you want. But that's one whole camp that those things are inherently distinct and should never overlap. Or there's the third camp that says just start simple and evolve in place. And a subpart of that camp says, if we over time decide that we had something that was not temporal and we want to make it temporal, we'll just change it in place. We'll be agile about it. So that's the camp we're in. That's what we're going to talk about today. The point of today's exercise is that upgrading an ontology in place is not trivial, but it's also not catastrophic. It's not nearly as much work as a traditional system. And we're going to go through step by step, detail by detail. So like I said earlier, our simple model has been working for a long time. When you want to bill a client, all you really need is your current billing rates. It's only for analytics and this incentive plan where you have to go back over time. If you changed somebody's billing rate now, but then used that for something they did 6 months ago, you'd get a different answer than what had been true 6 months ago. So that's the essence of the thing we're doing here. Just to give you a rough idea, here was part of our T box, our terminological box, drawn in Visio. We have a tool that generates a howl from Visio. And it was a very simple model here, this part of it anyway. Employees have billing rates. Now, we could have been even simpler. Billing rates could have been a data type property. But, we're pretty committed to getting formal definitions of everything. In this case, a billing rate is a magnitude. It's dollars per hour. One of the nice things for that is over time we could have dollars per month, dollars per week, euros per hour, and all that. We could convert back and forth. So we think that was a pretty good starting place. Our whole database is built up around this particular model. Now let's take a look at where it's going to go from here. I actually did a simple query. We have our data's in Allegra graph. Just did a simple query. So give me a bunch of time charges. Here's all this stuff in Allegra graph, and I just randomly grabbed one and did this in an Allegrograph's product called Gruff. I'll do a little bit of live stuff here. It's really a lot of fun because you sort of forget over time how all these things are wired up. But in this case, I just lost my little pop-up menu. Oh, there it is. I want to see who else. See, I had drawn this out. I said that time charge was for this person. This blue line tells you is the consumption of this person's time, who's an employee and also a person. Happens to be Jim Reitzema, guy who used to work for us. And he was wired up through the HAZA relationship to this thing that we call the architectural project manager, but really it's a billing rate. Now, this is all real data, but it's been anonymized. I ran it through a routine. Our billing rates aren't really to the numbers. Sorry to disappoint anybody who thought they were going to get a bargain. But anyhow, this is a random number that was generated. And then when I clicked there just a second ago, I'll do that again because I did it pretty quick. It said, these are incoming links. Who else shares that same, and scrolled off the page there. Ooh, that's kind of weird. But anyway, who else shares that same billing rate? So that was kind of the point here, that in our existing model, many people could share a billing rate. And the billing rates were not temporal. Now let's look at what we're going to change. You have to make a couple of decisions when you come to this point. The first one is, what is it that we're going to make temporal? Is it the billing rate itself, that orange box that we were pointing at? And we certainly could, if our standard rates change over time. For instance, we were approved by the GSA and we have rates in there, and if over time they change, we may want to change the standard rate there. So that orange box that we saw a minute ago could become temporal. Or we could change the relationship of the employee to the rate. In other words, assigning them to a rate is sort of like assigning someone to a position. So if someone may have been an ontologist for a year and then the next year they could be a senior ontologist. Now if we do that, if we do the first way, we've just got the same rates and we're going to promote them to be temporal and add effectivity dates on them. But the second case, we have to introduce another object in between the person and the rate, or the position, if you will, that is essentially the assignment. And that's what we're going to do for this exercise. We actually could do both. It makes it a little bit more complicated, and for our purposes, we really need to do the second thing. So here's our new T box. This big thing in the middle is what we just added. We had the billing rate remains the same. The employee over on the left now has one less necessary property, and that is they no longer have a HAZA that points to their billing rate. They still have one to their pay rate, which, by the way, we're not using at the moment. We still do the payroll in QuickBooks, but we'll change that at some point as well. So what we've got in the middle here is descended from what in GIST we call a temporal relation, and a temporal relation just has effectivity dates and connects two things together. It takes the place of a relationship, essentially. Now, some people call that a reification, but I think technically it's not exactly right. A reification is where you keep the original RDF assertion and add other assertions to it to say something about it. Here we've decided to move it into the realm of the model, and I tend to call that nominalization. The term nominalization in English means to take a verb and turn it into a noun, like the way we say move is a verb and movement is the noun form of verb of move, or assign is a verb and assignment is the nominalization. So that's pretty much what we've done here. Here's our new design. To give you an idea of where we're going to go with this in the A box, previously we had employees pointing directly at their billing rate. Down below, we're now going to have this new object in the middle, the temporal relation object, in this case the billing assignment, and each employee, they will not be sharing assignments. Obviously that doesn't make sense. If you share assignments, then when you promote one person, the other person gets promoted. But they may be sharing the same billing rate. And of course the other thing that changes now is that one employee can have more than one assignment, not necessarily at the same time, but for a while they may be assigned as an ontologist, and then later as a senior ontologist. In fact, that's the whole point of this. If we don't do that, then we haven't actually changed anything. So that's where we're going with the design. So what you need to do is first, luckily we have kind of a standard, as you can see here in the middle where it says context. That's our named graph. When we originally loaded up the triple store, we put a URI on the name graph so we can come back later and just delete the T box. Now, if you're used to traditional systems, this would be a bizarre thing to think about. We would be deleting all the table definitions but leaving the rows in place, if you will. But in semantics, that's fine. We take out the T box, put in a new T box, and everything that was wired up before will still be wired up. It's actually an incredible thing, and it's part of what makes these kinds of updates possible. Now we could have, because this was only two little changes, we didn't have to drop the whole thing. We could have added the new billing rate assignment and then just removed the one property, but this is kind of the way we've evolved to do this. So now, once we got to that point, we realized, we need a new use case, because at some point when we promote somebody or make somebody a senior ontologist, we have to go in there and declare what date effectivity that is. So that's the next thing we have to do. We also, along that line, have to decide for changing the existing data. Are we going to try and write a script and change in place, which we've done many times? But in this case, there's only a few dozen people, and I have to build the use case anyway. So once I build it, I might as well just use that, type them in, and be done with it. If there was very many more folks, I probably would write a script, but that's what we decided to do. That's what we're going to do in this little presentation. Luckily, we've got a model-driven environment here, and this is a little snapshot of part of it, where we just go in and describe what we want the use case to look like. In this case, it's a use case about billing rates, and they have, or billing rate assignments. And in that first line, you can see they're connected to billing rates. They're also connected to personnel, and you can see part of a little Sparkle query in there, and the little selection that says you have to select somebody, and then the planned start and planned end are the effectivity dates. So given that, if we save that, that creates a form that looks a lot like this. We can come in, it's a little, there we go, and you just type in new people and blah blah blah. So it's just it just creates an interactive form you can update your database with. I've put a couple of them in here. You can get the pattern. Scott from 2013 to the end of that year had one billing rate, and then later had a different billing rate. Again, made up numbers, but you get the idea. So then, once we've done all that, we have to get rid of those triples that directly connected the person to their rate. And this is the kind of query you'd do for that. Just go find all the employees and make sure they're either employees or subcontractors. It turned out we also used the same model here for our subcontractors. And then get wherever we directly wired up the employee to their billing rate through that has a relationship, and we're just going to delete those triples. So we're just right in the model there, taking out the old way we were doing it. Now, once you've done this and reassigned everybody through a temporal relation, you may later say, oh yeah, but I really want to have a query that gives me what everybody's current billing rate is, because for estimating new projects and the like, you need something like that. This is kind of a neat little example. It's a little bit complex, but essentially the inner query here says select employees. There are employees that are connected up to billing rates. They have start dates and end dates. I guess I didn't need the start date on this one. And then give me the maximum end date, so the most recent assignment. It could be somebody who's left 5 years ago, but that would be the most recent, or somebody who has a arbitrarily large end date out there. So give me the maximum for each employee. That's what this inner select does. Then the outer select says, for that employee, go hook me back up to that recent date and give me the billing rate assignment, because I need from that to get the billing rate itself, and give me their name. So that'll get us, if you just want the current rate, that'd be fine. Now, we had an analytics query, a very complex one. This is only part of it, because we take a lot of the data out of the database, put it in spreadsheets, and take it over to QuickBooks, that kind of stuff. In the old query, we were pulling up, total hours and earned revenue and things like that by week. So the part of, and I've left out a lot of it, but the part I want to highlight is that we had people that had billing rates, and billing rates had decimal values that were rates. That's the part we're going to change. With this new thing, it does get a little bit more complicated. So I commented that out and said, okay, the person now has a billing rate assignment and has a start and end date, and we want to make sure that the time card, and the time card also has an end date. We just want to make sure the time card's end date is in between the start and end date for the assignment. In other words, go get me the billing rate that's in effect for every single time card. That's how that works. So once we got that, we have to test it. I'm doing all this in a sandbox account. Obviously, I told you it has fake data, and then we'd have to take this. That's what we're going to do early next week. I'm doing this over the weekend, but we're going to move it into production next week. So, just to summarize, once we made this change, everything downstream, our payroll system and our analytics and our dashboards and all that kind of stuff worked just fine now that we've made the change. The total effort to do all that was probably close to a person day spread over the weekend, maybe a little bit less, but we still got a couple more hours to move that into production. We don't have a really rigorous DevOps thing here yet, but the point is that's not much penalty for deferring that whole decision, and I think that's our point. You can get started. You don't have to agonize over whether every single decision is correct, because it is possible to change your mind, upgrade in place, move forward. You won't have broken very much. It's nowhere near the amount of effort in a traditional system where you're dropping tables, rewriting code, all that kind of stuff. It really is a pretty straightforward, easy thing to do. So I hope that helped you guys understand both temporality and how you update a triple store in place. Thanks.